Awesome. So why don't we get started? Let me kick things off by introducing myself as well. So my name is Mustafa, head of engineering here at Linea. And fun fact about me, I grew up in 3 different countries. Cool. So let's get started. So today we're going to be talking about hosting LineaPy for better data science collaboration. So like I just introduced myself. Also Andrew is one of our brilliant software engineers. We also have on the call Shardul, founding engineer, and Ian, who's an intern, but really good to see everybody else. And I think the agenda for today is to give a brief intro of LineaPy. What is LineaPy about? What are we trying to solve? Then Andrew will talk a little bit more about how LineaPy hosting can help data scientists, and he'll do a live demo of that, which is always fun on a Friday. And then I'll conclude by talking about some exciting feature work that we're working on and really excited to release. And we'll also leave some time for questions so people can ask away. So why don't we get started? So easiest way to get started is talk a little bit about our goal, right? Like what is it that we're trying to do? And LineaPy goal is really to try to move from prototypes to pipelines with as little friction as possible. So this is kind of a very, very high level of what we're trying to do is enabling data science prototypes to move to production. But it's always important to talk, be a little bit more concise. So for example, what is it that we mean when we say a pipeline? So what we mean is everything, actually. So everything is a pipeline in a data science environment. And the reason for that is there's an interesting slide here that I missed. Okay, so let's go back here for a second. Yeah. So LineaPy at a high level is the library that allows you to do a few things. So it allows you to clean messy notebooks, revisit previous work, create production data pipelines, and try to do all of these 3 things with minimum code overhead. So this is something that we really care about, is trying to make the process to doing all of these 3 things and even more very non-intrusive for data scientists. And that's why it's important to be clear about what we talk about. So one of the things that we want to talk about, again, is pipelines. And the idea here is, what are pipelines? And like I just said earlier, everything is a pipeline. So the idea here is that if you think about data science in general, it's an idea of transformation. If you're taking some input and you're doing some processing and some transformation that reduces it to some output. So for example, you can think of the ETL pipeline. That's usually happens in the form of starting with a table, doing some pre-processing or some processing on it, and then ending up with another table. If you think of analytics, that's another way of looking at it, where you can start with some table, doing some processing on it, and essentially receiving or ending up at some chart. You can also think of model training as another pipeline, where you start with a table and you do model training, your favorite training framework, and you end up with a model. And even prediction, you can think of that as a pipeline, where you have a model that's already been trained, you have a table with some data that you're going to use, and then you come up with some transformation that's usually a prediction, and that's usually also a table. And I can go on and on and on about how a lot of the data science tools are essentially that transformation, right? And all of these things that we see at the bottom, right, like the input or the output, are things that we call in Linea's lingo artifacts, right? So all of these artifacts at the beginning or at the end, and the process that creates them is things that we're really interested in capturing. So, and we're not just interested in capturing, but we're interested in running these pipelines over and over and over with different data sets, maybe, or different things. So how do we run these pipelines? Well, we start by looking at 2 environments that are kind of siloed right now. So we have our development environment, and this is usually where we create these pipelines, but we also want to run these pipelines in production. And the problem here is that these environments, due to separation of concern, have a lot of different separate tools, right? So in the development environment, you have pandas, maybe a notebook, you're working with matplotlib. In production, you're looking at Apache Spark and running things maybe with Airflow or MLflow or Kubeflow. And the idea here is that separation of concerns allows you to do things that are good in one environment. That's not necessarily something that you want to do in another environment. So for example, when you're working with Spark, it's something because you're working with massive scale of data, whereas when you're developing the pipeline or development models, for example, you're trying to explore a smaller data set to try to slice it and look at it and understand what you're trying to do. But you still need to move from one environment to the other, right? Like once you come up with a pipeline that you would like to execute, you want to be able to move from development to environment. So what does this process look like today? Well, it's a big mess. And this is really where LineaPy excels, right? It's trying to bridge that gap by trying to between these two environments and making it simpler and a lot less friction, with a lot less friction between these two environments. So how do we do this? Well, it's magic, but not really magic. What we really try to do is essentially we start in the development environment, and all the user have to do, or the data scientists have to do, is they need to import LineaPy. So once they import LineaPy, this allows us to do a few things. So what allows us to do is essentially allows us to capture everything in your development environment, right? So as you're coding, as you're writing, as you're exploring different things, we'd be able to essentially capture environment that includes all the libraries, the dependencies, contextual information. And what we do is we use that information to create what we call a linear graph. So that linear graph, you can think of it as an intermediate representation, right? A semantic layer that allows us to understand the dependencies between all of your variables, the mutations, the side effects, everything that you've that happened so far. Once you have that, graph, that intermediate representation of what the data scientist has been trying to do, it's easy to translate that, right? It's easy to do a lot of things with it. So for example, if, a data scientist is interested in a particular model that they came to after a bunch of iterations, all they have to do is say lineapy.save was that name of that model. And what we'd be able to do is we would be able to create a linear artifact, right? And linear artifact essentially represents that process, right? The idea of being able to create the clean slice of code, essentially the subgraph that touches everything that this variable or this model is dependent on, and generate a clean code from start to end that allows you to run or recreate that model. But there's also something that's more important, is that because you have the full session context, right? You have the full graph, you would be able to also look at different artifacts that are created within this session, and you can use it to create a pipeline, right? So now I can create a pipeline. You can imagine I can have a pipeline that says I'm going to do some pre-processing, some training, some validation, and I can connect these functions by doing that LineaPy pipeline. So as you can see, like in terms of what we're doing underneath those, there's a lot of work, but in terms of what the data scientist is doing, it's essentially literally 3 lines of code. And then what we can do with that is essentially you can translate these pipelines to any orchestration framework that runs in production. So you can, do Airflow or Spark or Dask or MLflow. You'd be able to translate that. And this is where LineaPy again excels, is being able, by having that intermediate representation, we can transpile to any of these production orchestration framework. So this is kind of like at a very high level what we're trying to do and what we're working on. Andrew will take it from here, and he'll talk a little bit more about how do we do this in hosted or in local execution environment.
Cool. Thank you, Mustafa, for the introduction to LineaPy. Next slide, please. Yeah. So basically, diving a little bit more into the magic of how this actually works, we can try to answer the question of what do I actually need to run lineapy.save and lineapy.to pipeline, right? What are the components needed to get this to work? And this is really all summarized in this little component diagram right now. So when you call lineapy.save to create an artifact, LineaPy is talking to something called the LineaPy Artifact Store. And the LineaPy Artifact Store actually comes in 2 components. It comes with a database, which keeps track of all the artifact metadata, such as when it was created and what's the lineage or relationship with other artifacts. And the Artifact Store also comes with remote file storage, or just any type of file storage, which actually holds the artifact values itself, like the pickle model file. The other really important piece of the LineaPy experience is toPipeline. And what toPipeline actually does, it creates a set of files that are required to set up the pipeline in whatever framework that you want. So when you call toPipeline, you actually specify the framework, and it creates the files that that framework will then understand. And if you have an orchestration engine that's running that framework, you can basically copy these files over, and that orchestration engine should be able to immediately understand the pipeline that you specified through Linea. So LineaPy by default actually, out of the box, it runs with a local artifact store, and it doesn't come with an orchestrator. So if you want to set up LineaPy and play around in your local environment, it's super, super easy to set up. But the thing is, we actually do allow you to configure to LineaPy to connect to a hosted artifact store and other orchestration engines through the development environment. Next slide, please. Yeah, and so the question is basically, if you're self-hosting, why are we giving users the ability to self-host these components and connect their development environment to them? And this really comes down to how we think self-hosting LineaPy can help. And to go even further, one of the core propositions that we believe in is that data science work is inherently collaborative. And that we believe that by having a shared artifact store and orchestration engine, teams are enabled to collaborate by sharing their workflows and pipelines and artifacts, as we've mentioned previously. This allows teams to modify and build on top of each other's work, and really empowers them to do more. And just to really hammer home this point to illustrate why we think this way. For the data practitioners among us, how many times have you heard a colleague say, "Hey, can you send me that notebook that you were working on? I think that this piece is cool, right? Or I want to be able to take your model and fiddle with it." And this is the type of environment that we are really trying to foster in data science teams as well with LineaPy. Next slide, please. Yeah, cool. So our demo is basically, laser focused on demonstrating that it is relatively easy to host the components for LineaPy. And just to dive a little bit more into details for our demo environment, we're setting up actually 4 major containers in a Docker setup. And the 4 containers are the following. So we have a Postgres database and a MinIO hosted S3 bucket. So these 2 components, as we discussed previously, will be the database and the remote file store for the LineaPy Artifact Store. The demo will also include a hosted orchestration engine. We're using a standalone Airflow instance for this demo. And then, of course, we're also providing you with a pre-configured development environment with a Jupyter Notebook and LineaPy tracing installed already. Next slide, please. Cool. So let's actually dive into the demo. I think at this point, I should probably take over screen sharing. Continue. Let's just share my whole screen. Alrighty. And Mustafa, can you copy the link in this slide for everyone? Yeah, so this link actually goes to our blog post, and our blog post has a link to the demo scripts here. And this is basically has all the files that you need to follow along with the demo after the fact. Cool. So setting up and starting the demo is super easy. So once you're in the right directory here under the LineaPy project, it's under self-hosting LineaPy. It's just Docker compose up. And this will immediately start to spin up the 4 containers that I've mentioned earlier, the artifact store, the Airflow standalone engine, and the LineaPy development framework. And we can wait a little bit for these to come up. It looks like the MinIO started first, so let's connect to that. So this is going to be our remote file storage, which is, oh no. What? Hang on a second. Okay, I'm just really bad at typing. Which will basically host the values for the artifacts in our artifact store in this bucket here. And this demo also has a little bit of training data that's going to be used for part of the demo that I'll demonstrate later as well. And then this demo also creates a local Airflow, which doesn't have any DAGs in it right now because we haven't created any pipelines yet, right? But we'll come back to this piece. And then, of course, we have the Jupyter environment as well. And to go through the demo, we have an example Jupyter notebook. And this notebook is really focused on an example use case of let's predict house prices. And I'm going to go relatively quickly through this notebook for the sake of time, but afterwards you can take your time and actually look through a lot of what we're doing. This is like a pretty typical data science workflow. So the first thing that's really important is we're importing LineaPy. This is kind of what powers all of our magic, right? And then we're getting our training data from the S3 bucket that I showed you earlier. It's under data aims train clean.csv. And at this point, I'm going to start going through things really quickly. But we are doing some exploratory data analysis, really trying to understand our data, creating a bunch of plots, let's see if this one will show up. Yeah, like pair plots for feature correlation, and munging our data a little bit, trying to get it into a format that we really, really like. And at this point of the notebook, we think we have our training data all formatted correctly. And as Mustafa said earlier, we can create an artifact out of this training data. And now Linea will save our training data and all of the process that was used to create it. And what's really cool here is that we can actually print the code that's used to generate the artifact. And Linea, through its tracing, is actually smart enough to figure out what the minimal set of code is that is used to generate this artifact. So for instance, if you look at the code for the training data, it actually does not contain any of the plotting because LineaPy has figured out that the plotting is not necessary to regenerate the training data. Yeah, so that's one of the cool features that we have. So continuing on, once you have your training data, it's pretty common in the process to be like, hey, let's train a model, right? And in this case, we're going to be trying to predict the sale price of these different houses. So, just for the sake of this example, we're going to train a linear regression model, super simple stuff. Okay, our model looks great. We're interested in the model as well, obviously. So we're going to call lineapy.save, and we're going to save this model as well. And here comes the really cool magic. So LineaPy can create pipelines to reproduce artifacts that we've saved before. So in this case, we're going to create a pipeline that reproduces our training data and our housing model. And so as soon as I call this, we're going to generate the files, the pipeline files that I've discussed before. And the rest of this is basically, we can take a look at some of the pipeline files we've generated. The one thing I do want to point out here is that when you look at the code to generate the model artifact, we can actually see that it depends on the training data artifact. And this is because LineaPy, through its tracing, has figured out that the model depends on the training data and is able to factor out that common piece of code that generates the training data so that we don't need to run it again in our pipeline. And if this demo worked correctly, yeah, the Airflow instance picks up on the DAG files that I've generated immediately, and we are able to run this pipeline DAG as well. And this Airflow instance is basically our production environment, right? So that was super quick. I ran the 2 pipeline, and now we're already in the production environment, and we're seeing these tasks that are creating the training data and the model again going through and succeeding, which is really cool. The other thing I want to really quickly demonstrate as well is the fact that these components are self-hosted. And so you're actually able to connect to them from other development environments. So I have another environment here, which is actually not spun up by the Docker container. This is running locally. And I'm going to demonstrate that I can actually connect back to the same artifact store and access the training data and the model that I saved earlier. So this is in a totally different notebook. I'm going to do the same thing, import LineaPy. There's a little bit of extra stuff here because this is my own local environment. I need to set the options again. So the demo environment does this for you. But once I set the options to connect to the artifact store, I can actually get the model and the data back from that artifact store, right? So this, like right now I'm pretending to be another user, right? And I've gotten the model and the data from one of my colleagues. And just a quick example, I might want to take one record from their training data and call model.predict on it, right? And yeah, I can basically use the model and the training data that my colleague has saved for me previously, which is really cool. Yeah, so that's the demo. I think we have a couple more slides to go. So Mustafa, I think you can take it away for the rest of the talk.
Thanks, Andrew. Let me find the right button to click. And let me know when you see my screen. Cool. Awesome. So yeah, so this was a demo that showed you how to go from a notebook to a pipeline that you can easily execute locally. You can even connect it to a remote artifact store and be able to collaborate with others, right? And I think that's really powerful. But I don't know about you, whenever I'm trying to do something, I'm trying to get something done, the last thing that I want to do is mess with Docker, or mess with Kubernetes, or mess with a lot of these things, right? So if I'm really trying to get things done, I want to make this also something that is not in a bottleneck for me, right? So if you remember, our call to action at the very beginning is it's about simplifying data science in production and making it as painless as possible, right? Like we want to be able to make sure that people can get to insights as quickly as possible. So one of the things that we're really excited about is we're working on hosting these components as part of the Linea platform. So to provide you with an even more seamless and quick experience of enabling the whole data science team to move ideas in the development environment quickly to production, this is essentially what we're trying to do. So we're super, super excited about what's coming down the pipeline, no pun intended there. But we're really looking forward to releasing a platform that allows us to do a lot of these stuff even more seamlessly than what you saw today at the demo. So at this point, this is kind of like concludes where we wanted to present today. I want to take a chance to acknowledge everyone who's in the call, including the brilliant engineers who have been working really hard on making this a reality. These are links if you want to sign up for the, especially the QR code. You can scan that now, and you should be able to sign up for the platform experience. And then this is our social media presence, our Slack, our GitHub, our LinkedIn, YouTube, and Twitter as well. And then I'm more than happy to take questions at this point.
Hey, I have a quick question for Andrew, if you wouldn't mind.
Yeah, go for it.
Andrew, you went through the notebook quickly, obviously. The settings for sort of your, I guess, the whole, setup of LineaPy, like what orchestration, where are things saved, where does that occur? Is there like a configuration, or is that all done in the code? I didn't get a chance to really see how it worked out. So let's say you wanted to switch from Airflow to Prefect, where would you change that?
Yeah, that's a great question. So Mustafa, I'm going to undo your screen sharing again. So the way this works in the demo environment is actually there's a LineaPy config.json file, which you can change. And the way a demo environment works is that we basically mount this file into the container that's running the Jupyter environment. And if you noticed that in my local environment, I had to set these options manually. So we actually have multiple ways for users to specify the options that they want to run with when starting their development environment. And this is basically where you set up all those configurations. Yeah.
Cool.
Actually, in terms of pipeline, right? So at that to pipeline, if you want to move from Airflow to, let's say, Perfect, that's also like there's a flag there that you would change that allow you to transpile the code to Perfect as well.
Yeah, just really quickly, let me share that piece of code again.
Yeah, and another thing I wanted to highlight here is for this demo, we have gone only with Airflow instance in the hosting environment, self-hosting environment, but you can very well add a prefetch Docker, or any other orchestration instance into the Docker Compose file, so that you have that environment to run this, and then you can do what Andrew is about to show, and use different framework. Essentially, go ahead, Andrew.
Oh yeah, I was just pointing out, like, yeah, you can parameterize to pipeline and produce files that are understood by different frameworks.
Cool. Quick other question. LineaPy is open source, or how do you guys commercialize this?
Great question. Yeah, so LineaPy is on open source. So if you go to our GitHub, that's essentially you'll find everything there. And then the commercialization is essentially the hosted platform that I mentioned we're working on releasing. So if you want to take this and try to do the orchestration yourself, that's essentially what we'll support as far as our support will go now open source, and then we can manage the execution and orchestration for you as well in the hosted platform. So Jad, Lazar, you guys have any questions? Yeah.
And again, this might be a naive question. What about very large data sets in the multi-gigabyte, terabyte? How does that work in terms of reliability of execution, reliability of transfer of the directed acyclic graphs, etc.?
So there is a couple of pieces here. So one is essentially part of being able to set up that pipeline, you'd be able to also set up parameters that essentially the input to that pipeline. So when you're working on a notebook, right, you might be able to load just a small partial data set that you're using to inspect, and then you want to run the pipeline on a larger data set. So the idea here is that you can very quickly essentially parameterize that pipeline and say, like, for the larger run, for the run that will go in production, I want it to run with the larger data set that's multi terabytes. The other thing that's interesting is because we create this idea of a pipeline that has multiple stages, we can annotate these multiple stages with different orchestration frameworks, right? So right now we can, let's say, do it all in Airflow, but you can imagine, for example, one of the other integration that's coming down the pipeline as well. And again, no pun intended here, but one of the things that we're working on is Ray, which allows you to parallelize the execution of for training, for example. So the idea here is that as a data scientist, you don't have to worry about that. What we'd be able to do in the hosted platform is essentially annotate those functions, the training function, for example, with a rate operator, and that rate operator will then be able to execute in parallel in a larger cluster and be able to train on a larger data set without having to do anything on your end.
Sorry for maybe asking another dumb question. Where's the notebook or the demo? What's the link? Is that it here?
No, so this is the link for the bit.ly, but I put the link in the chat so the chat should have the link for the blog post, and there you should be able to access everything there.
Yeah, okay. I see it. Thank you.
Awesome. Cool. We're a couple of minutes over time, or no, we're actually doing okay on time. We have a couple more minutes. If other people have any other questions, happy to answer them.
Maybe a quick question on how do you do the data cleaning, or rather the code cleaning, automatic code cleaning when you save code and when you try to retrieve it back? How do you approach that method?
Sure. Andrew, you want to take that one?
Sure, I can take that one. This one's probably easier to answer with the original slides, which is basically most of the magic that happens on this slide here. Can you guys see that?
Yeah.
Okay. Yeah, when we're doing the code capture for the linear graph. So when we're doing the code capture for the linear graph, we're actually building out which variables have dependencies on which other variables. And so when you're doing your exploratory data analysis and creating plots, you're actually creating like pieces of the subgraph that are that the final like training data will not actually be dependent on. And so when we call get code on the final training data, it basically traverses this graph and finds like the minimal, what we call slice to or subgraph to reproduce that one artifact. Yeah, and that's kind of how it works at a high level.
Yeah, so I can give a quick example of that real quick. So imagine if we have 4 lines of code, A equal 1, B equal 2, C equal 3, and D equal A plus B. So when essentially you import Linea and you run these four lines, essentially you'll end up creating 4 nodes, right? A node for A, a node for B, and then node for C. Each one was the corresponding value for 1, 2, 3. And then there's another node for D, which will be connected to both A and B, right? Because it's essentially dependent on both of these. Then the next thing that would happen is if I would say lineapy.save D, right, what will end up happening underneath it is it's going to understand that D is only dependent on A and B. So if I were to say, hey, get lineapy or lineapy.get code for D, what would it do? It would essentially return A equal 1, B equal 2, D equal A plus B, and it will leave out that line of C equal 3 because it knows that that line is not dependent in any way, or D is not dependent on that line in any way. And that's essentially kind of very high level what code slicing would do.
Okay. Because I'm just asking because I was doing something similar, so it's really like a big unexplored area, I think, and a lot has to be done there. And we were dealing, I think, with a lot of sparse matrices, and for example, how to do matrix multiplications, where you would save a lot of processing time by cutting with different methods those sparse parts of the matrix. And some of those, for example, numerical operations that could be also done automatically, I think could be also integrated.
Yeah, I just ran Mustafa's demo, I think. Mustafa, is this right? A equals 1, B equals 1,
Yeah.
C equals 1, D equals A plus D.
Yeah.
Okay, yeah.
Yeah.
So basically down here, we can see that the artifact D here, if you trace it back through this call node here,
Connected to A and B.
yeah, it's connected to A and B, and actually C is not connected here. It's kind of hard to see, but yeah.
Yeah, understood. Yeah, that's really interesting. Thank you.
All right, so I think we're almost at time, so maybe one last question. If anybody has anything else they'd like to ask. I get to ask a question to the audience. How can you see LineaPy helping you? So, Chris, what are maybe your thoughts there?
I'm sorry, what was that?
So the question is, how do you see LineaPy helping you?
Oh, I mean, just like messy notebooks, obviously. We're in messy notebooks all the time, so yes. I think it also obviously expedite things once once you've done your messy notebooks. That's just the beginning, but with this, at least you can move on pretty quickly to getting things in production. So also, I see that more in data science, like analytics wise, it's pretty cool. You can do that. It's not just pure machine learning stuff. So.
Lazar, any thoughts on first instinct reactions to what you saw?
Yeah, the messy notebook's always an issue, but of course, running it to production so fast, it really seems like magic. And I really love the part with the automatic cleaning and really figuring out to minimize the whole code and how to get to the solutions. It really looks good.
Awesome. Cool. Well, on that high note, reference to Seinfeld, I think we can call it a day. Thanks everyone for joining us today. Like we said, the links are online. This video also is recorded and will be online as well soon. And you have a link to the notebook. And if you have any questions, please feel free to reach out to any of us. We also have a Slack community, so feel free to join that as well. And if you have any questions, we'll be able to answer them as soon as possible.
Thank you.
All right. Thanks, everyone.
Thank you, guys. Bye.
All right.